Okay, welcome to the video version of the discriminant intro slides. So our objective is to find the discriminant, which we'll define in the notes. This video will cover slides 1 through 7, and then the second video will start on slide 8. So let's find out what a discriminant even is. So first of all, I just want you to know when you see the yellow, that's my commentary in writing. So it's not the notes. So in general, you may type the notes from these slides and this video directly into your document where there are blank spots. Or if you prefer, you could take the notes on a separate sheet of paper. Or if you have a printer, you could print the assignment and then write it. If you choose option B or C though, please do make sure to upload a picture to submit it with your assignment. So our notes. The discriminant determines the number of real roots in a quadratic. Real is a type of number. So the discriminant is represented by b squared minus 4ac. This is a formula for the discriminant. Based on the answer, you can determine how many real roots there are, or how the roots are, what types of roots there are. You will later see this in the quadratic formula, but more on this by the time we get to Friday. Okay, so if you do your discriminant, b squared minus 4ac is greater than 0. You do it, it's greater than 0, or it's a positive number. That means that there are 2 real roots. So if you do your discriminant, your answer is positive, it's greater than 0, you have 2 real roots. In contrast, if you do the discriminant and you get 0, the b squared minus 4ac is equal to 0, the discriminant is equal to 0, then that means you have a double root. So there's still 2 roots, it's just they're both the same exact number. That's what a double root means. So just to make it clear, if this is a graph, this graph will have the vertex directly on the x-axis. So the max or the min will be directly touching and it will bounce off. That's what a double root is. Versus the previous slide, 2 roots, you'll see 2 x-intercepts on a graph. Okay, there's one more option. So first option was positive, second option was 0. You may be able to predict what the third option is. If b squared minus 4ac is less than 0, it's less than 0. That means the answer, the discriminant, is negative. In that case, there are 2 imaginary roots. So imaginary roots, meaning they're imaginary numbers. You will not see these roots on the graph. You're not going to see them as x-intercepts, but they are actually numbers. They're not fake. So if you missed last Thursday, here's a note about imaginary numbers. Or if you were here, but you don't really remember, here it is. So imaginary numbers, those are the ones that involve I. So I is the square root of -1. And if you've got an imaginary number, you're not going to see it on the graph and you're not going to see it on a number line, but they do exist. They're not actually fake numbers. They are numbers. They're just a different type than we've used before. So the discriminant lets us figure out if our roots are real or imaginary. And it tells us either there's 2 real roots, there's 1 double root that's real, or there's no real roots because both are imaginary. Either way, no matter what, all quadratics have 2 roots in total. 2 roots. 2 real, 1 double, or 2 imaginary. That's 2 roots regardless. So that's kind of a big deal. Like a really big deal in math. It's something called the fundamental theorem of algebra. And what it really says is that since a quadratic has the biggest exponent of 2, like its biggest exponent is 2, that means that there are 2 roots. So if you have a polynomial that's cubic, if that goes to the 3rd power, you might be able to predict how many roots there are there. But right now we're focused on quadratics, and they always have 2 roots.